Assalamu alaikum, I am Mahmoud Sameh, and inshallah, in this video, we'll be briefly explaining and answering VSEPR questions. First of all, VSEPR stands for Valence Shell Electron Repulsion, but it's commonly known as VSEPR theory, the VSEPR theory. Briefly, it's a model used in chemistry to know the geometry of the molecule from the number of attached bonds to the central atom. So it's something nearly like the loose structure, but it's in a 3D model, and its purpose is to know the geometry of the molecule. So the first VSEPR question is, which of the following loose electron dot diagrams represents the molecule that contains the smallest bond angle? As we know, the VSEPR includes the bond angle in the table of it. So there are the choices A, B, C, and D. In this question, you should be confused between A and B, as both of them has four domains, while C and D has three domains. So definitely A and B will have smaller bond angles than C and D. But if you notice that the difference between A and B this domain. It is not a bonding domain. It's a valence two electrons, two valence electrons. يعني. So as you hopefully know that the two electrons has a higher repulsion than a normal bonding pair. So it will make the space between these bonding pairs is smaller than these ones. يعني. So by that, B has a smaller bond angle. So the answer is B. BR F5, number of bonding domains, non-bonding domains, electron geometry, molecular geometry, and bond angle. So in this question, he wants us to identify all of these elements, and the BRF5 loose diagram is drawn for us to help us in answering the question. As we noticed that the number of bonding domains are five. One, two, three, four, five. So yes, the number of bonding domains is five, and the non-bonding domains is one, and the electron geometry is octahedral because this molecule has six bonding domains, and as you also hopefully know that the six bonding domains means that this shape is octahedral, and the molecular geometry of this shape is square pyramidal, and the bond angles are 90. In VSEPR question 3, he wants us to choose which diagram best agrees with the experimental data presented. So the experimental determined information about cyanic acid is presented below. So in this experimental data, the whole issue is that the bond between the O and H is slightly tilted downward. First of all, we should look at the two diagrams. Let us start with diagram 2. As we noticed that the N has four uh, full electron domains, which does not differ the rest of the molecule's angle, as all of them has two electron domains, which makes it 180 degrees. So this molecule is straight. It does not have any tilts except in the N atom, which does not affect the whole molecule. However, in diagram 1, the oxygen has four electron domains, which makes the hydrogen atom a little bit tilted downward or upward, because four electron domains means that the shape of this atom of this molecule is tetrahedral. And if you notice in the tetrahedral, wait a second. In the tetrahedral, this that's the presented molecule. In the tetrahedral, it is a little bit tilted downward, which makes it bent. So here the answer will be diagram 1, because the hydrogen is tilted downward as it is in the simulation. Of course, you should be studying these shapes, and keep them in your mind to know what will happen in every shape in the simulation. VSEPR question 4 says identify low structure, shape, and polarity of CH4 molecule. So the low structure is so simple. Actually, it is like this, and we can see that all atoms fulfill the octet, and the shape of it is this. It's octahedral. It has four domains. And lastly, the CH4 molecule is nonpolar as all atoms are spread out in an equal way. They are all symmetrical, so there is no any polarity in this molecule. And thank you for watching. Still, there is another part of the video. Wait for it.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everybody, I'm Mohamed Adnan. This video, inshallah, I will answer three questions about VSEPR. The first question is about the compound NH3. We should know the number of electron domains, the number of bonding domains, the number of non-bonding domains, the molecular geometry, and the bond angles. To know the number of electron domains, we should follow two steps. The first one is to draw a Lewis diagram. The second one is to count the electron pairs around the electron pairs surrounding the central atom of the compound. This is a Lewis diagram for NH3. The central atom here is N, and we have one, two, three, four electron pairs. That means we have four electron domains. And to know the number of bonding domains, we should also count the number of we should also count the electron pairs surrounding the uh, central atom, but يعني enter in a bond with with an other atom. For example, this pair of electrons is bonding with a hydrogen atom, and this pair of electron also bonding is bonding with another hydrogen atom, and also this is the same. So that means we have three bonding atoms, and we have these two electrons. This pair of electrons is not uh, bonding with any other atom to that, so that means this pair is non-bonding domain. So now we have uh, four electron domains, three of them bonding domains, and one of them is non-bonding domain. Now there is nothing to be explained more than to be memorized. If we have a compound has three bonding domains and one non-bonding domain, that means the molecular geometry will be trigonal pyramidal. And as we know, the angles of the trigonal pyramidal are 109.5. Now, the second question is determine the bond type, the shape, the symmetry, and the polarity of H2O. To know the bond type, we should know the type of the atoms in the compound. In this example, all atoms are non-metal, so that means the type of bond is a covalent bond. Is a covalent bond, and now we should determine the shape of this compound. So we will follow the same steps as the previous question. We will draw a Lewis diagram for H2O, which is like this, and the central atom will be oxygen, surrounding by four domains, four electron domains. Two of them is non two of them is non-bonding domains, and two of them and the other two are uh, bonding domains. Two of them are bonding, and the other two are non-bonding. So that means the shape is bent. Now we should know the uh, if the if this compound is symmetrical or not. Now we should explain this on the simulation. If we want to know if this molecule is symmetrical or not, we should draw a line of symmetry to know if this atom is really has another atom that cancel that make it canceled out or not. For example, we will divide this atom into two parts, and here actually we don't have other atom that cancels this atom, and we don't have another atom here that cancels out this atom. So this compound is not asymmetrical because there is no atoms cancelled out. And if the compound is not symmetrical, that means it is apolar. And if the compound is asymmetrical, that means it is nonpolar. So the polarity of H2O is it is not it's non-polar, and it's apolar. Sorry, it's polar, and it's not symmetric. The second question is determine the bond type, the shape, the symmetry, and the polarity of O. Now, oxygen, as we know, oxygen is a non-metal, so that means the type of bond is a covalent bond, and we know that. And to know the shape of this compound, we should draw a Lewis diagram for O2, which will be like that. The shape is linear, as we see, because we can draw a straight line between the atoms like this. So it is a linear. Now we will determine if it is symmetrical or not. Actually, it's asymmetrical because each atom cancels the other. Each atom cancels the other. For example, if we draw a line like this atom will cancel out this atom. So that means it's asymmetrical and it is non-polar. Thank you for watching.